All right. Thanks again for coming to my session. It's 20, so I guess let's start. So as I said before, we are going to compare these two products, and hopefully it's going to help you to pick the right one in the right time. So I actually have those two numbers here, and those two numbers actually presents the ages of these products. So SQL Server is actually 30 years old this year, and many people say 30s are the new 20s. You know, it might actually apply for maybe humans, but for SQL Server, they are really trying to make the application much modern with adding all kind of new features every year. It's in the Azure SQL, you can use that, or the SQL Server on-prem, so which is kind of like a nice for SQL Server to have, because you can actually have on-prem version, and it's just not like the cloud only. Cosmos DB is 7 years old, so it's a totally new generation. The application is cloud-born, so it's much easier for you to kind of interact with the other new features like AI or any kind of other cloud product. It's much easier to do the interactions. So those are the kind of like the two numbers you can kind of see. When it comes to the community, SQL Server has been out there, so you are going to have a lot of support. If you have questions, it's going to be much easier to find it. Cosmos DB is new. We are trying to create a new user, the database for it and user community. So I'm always out there. My name is Hasan Savran. If you will have any kind of questions about the Cosmos DB, I will be more than happy to answer you from any of my, the social media accounts. And I'm a data platform MVP. This is my 6th year. I'm proud and happy to be part of the program. I am from United States, Cleveland, Ohio. I am my own company, Savran Web Consulting. Mostly I am really focusing on Cosmos DB, but I have a full-time job in a large insurance company, and I'm a senior business intelligence manager out there. So, and also, I'm not sure if you had chance to kind of play with the Cosmos DB SQL Studio owner. I'm the owner for that, and it's a VS Code extension. If we had some time at the end of the session, I will maybe give you some demo for that. And really, that's me. So let's actually start the presentation. The first thing I want to actually do here is I want to be sure that you understand what's really happening in the backend for a central database and a distributed database. SQL Server is a centralized database. So all those clients trying to pull data from the SQL Server, they don't really need to think about that much where the data is. That is database's problem to find the data and deliver that to you so you can do something with it. As long as you have the connection string, all the sort, aggregation, everything actually happens in the database. So that is great because, well, all the database in the same place. You don't need to really worry about that much. But in the meantime, that's really kind of put a bottleneck out there very quickly, especially if you have a lot of clients trying to read the data in the same time. Well, you have only one database server. So, and if you want to scale kind of like up that, you need to maybe like increase the CPU or increase the memory, but there's gonna be a limit for that. So it's easy to become a bottleneck for the SQL Server. Well, the Cosmos DB is a little bit different. So whenever you are actually organizing the Cosmos DB, you really need to think about where the database is. Because as you can see, all those Cosmos DB icons on the top, those are your databases. There's not only one, but there's X number of databases you're going to end up with. And that's going to depend on how much storage you need and how much power you need from the Cosmos DB. So all the clients in the bottom, whenever you try to pull data, you better know which database has the which data. If not, you're going to be in trouble because you're going to actually run this simple query. Well, I'm not sure. It looks like maybe we have 10 databases here. You're going to send that query to the 10 places. Well, each database is going to actually charge you for that. And that's most of the time people say that Cosmos DB is an expensive database. If you are going to pick the wrong partition key, it's going to be inexpensive. So you want to be kind of sure you are picking the right partition key, and whenever you actually send something like that, a query like that is going to go and get the right data from the right database. So the product ID here, for example, is really getting the data. It's almost like working like you go to the parking lot and you lost your car. How are you going to find your car? Usually, you just click the panic button, and it starts to blink, right? So it's working the same way in the Cosmos DB. So if we know the product ID, and product ID is the partition key, this query is going to actually go to the right database and get the right data for you. Now, since we are talking about the partitioning, let's actually talk about the partitioning in SQL Server first. In SQL Server, well, usually partitioning happens if you have too much data. Your table is getting larger and larger and larger. What usually happens is it takes much more time to find the data because, well, I/O time, the seek time is getting larger, and it just takes too much time to find the data. So the table is getting larger, and you want the salt, and the salt is in the other side, and it takes some time to actually reach the salt. How are you going to fix that problem? Well, in SQL Server, what actually happens here is you create smaller tables. And the schema is the same, and that happens actually in the back end. And the user still sees the one table, but as long as you have the partition key in SQL Server, usually it is the date and time. You say that, okay, 2010 year, data is going here, 11 goes here, 12 goes here. As long as year is in your where clause, SQL Server is going to actually go and get that from the smaller table rather than we go and hit each tables. So that's how the partitioning actually works in SQL Server. So it's the same database engine, but partitioning actually happening in different files. Cosmos DB works a little bit different. So when you actually set up the Cosmos DB first time, usually you don't have that much data, and you end up with just one database server, just like SQL Server. You have one server. And there are two numbers that you really need to know in Cosmos DB. The first one is the 50 gig data. That is the storage limit of one database server. As long as you hit that number or get close to that number, Cosmos DB will actually give you another database server. Or 10,000 request units. That is how much, I guess I can say that that's a horsepower of one server. If you are going to pass that number, then that means if you have less data, you are going to end up with another database server. So you are going to end up with, you start with one kind of like let's say a restaurant, and rather than making your restaurant bigger, you are actually franchising it and actually opening different restaurants in different places. Now, so if you look at a little bit more, I guess, technical than that, as I said before, we have physical partition. Physical partition is really the database server. We have a replica set in the database server. So potentially, your web application has 4 places to get data. In the SQL Server, you have only one. In here, in one physical partition, potentially you can get it from the 4 different places. That kind of explains why Cosmos DB is much faster, because you have options. As I said before, don't forget those two numbers, 50 gig and 10,000 request units. And you cannot change those in Cosmos DB, but by just knowing how much storage you have or how much the request units you need, you can easily figure out the architecture, how much servers you have and what you are really dealing with. You can easily create the diagram. So in our replica set, we have the leader. Leader is responsible for any updates, inserts, deletes, all of them actually goes to the leader. Then everything gets synced with the 3 follower nodes. If you have multiple regions, one of these followers actually becomes forwarder, which means that a change comes to the leader, syncs up with the followers, and the forwarder will be responsible to take that change and move it to other regions. So that's how the data actually gets synced in the backend. If we look at the logical partition is the place that you actually have some rights to change things. This is the place that you actually declare the partition key. That's how you actually group the data. Now, as I said before, you are really like you have your restaurants out there. Now you are actually organizing how many tables you are going to end up. So the only thing you really need to know here is the limit of the table, which is the 20 gig limit for the logical partitions. And hopefully you're not going to get close to that, because logical partitions should be really small and your data models should be really small. So hopefully you won't get close, but 20 gig is the limit for that. Now, let's actually see how this works. Let's say we have a container named orders. Our partition key is customer ID. So that means that we are actually grouping all the orders by customer ID. Looks like we have 4 physical partitions, which tells me we are dealing something like 150 to 200 gigabyte of data, because each of them can have 50 gig. Or we have an application, very busy application. Maybe we don't have that much data, but the application is pretty busy. Now, as you can see, each physical partition has a hash number. It's a minimum hash and maximum hash. It starts from 0 and ends up at the FF, which is the last one. So each time you have more data, that actually gets splits, and you might end up like 5, 6, 7 database servers. So if we want to actually insert a new order here, what happens in the backend? The first thing happens is we need to figure out what is the partition key. So partition key must exist in every data model you have. It's the customer ID, so the customer ID is going to get hash. From that moment, Cosmos DB kind of knows where this actual request is going to go, because as you can see, we have the hash numbers in each physical partition. So we are going to figure out which database needs to actually have this insert statement, and we are going to send that to only one database engine. So that's actually where we are going to save and find the data. This is going to work exactly the same way when we try to get the data. So as you can see, that's our select statement. My customer ID is John1234. The first thing Cosmos DB is going to do is hash the partition key and figure out where this request should go. And after that, it just sends that select statement only one physical partition, not 4 of them. If you have a different, so our partition key is customer ID, and let's say you want to select all and you have only order ID. If you have the order ID, then that means that select statement is going to go to the 4 physical partitions, and you are going to get charged 4 times, even you don't get the data. So that's why it's pretty important that you pick the right partition key when you actually set up your Cosmos DB account. Next one is query plan engine. Actually, this is the question I usually ask in the interviews and figure out what is the level of the person I am kind of dealing with in database levels. We have this question. Okay, we have the query select statement. Very simple. And we just take that, put it in the management studio, and I ask them, okay, how do we get this data? You create the, you click the execute button, and you end up with the data. But do you know actually what happened in the backend? How is SQL Server getting this data? The first thing SQL Server does is it just parses and binds the data. We want to be sure, first of all, that select statement is correct. Then we want to be sure that all that tables, all that columns exist. Then we want to be sure all the tables are good to go, and we are going to actually go in the query optimization. Query optimization is the place actually where Cosmos DB finds the best way to get that data, fastest way for you. To do that, it's going to go and check all the indexes, all the size of the tables, all the statistics, and be sure that everything is working fine, and it actually creates many query plans. You might end up with like 100 query plans. After it finds the plans, it's going to go back and figure out which one is the fastest way to get that data. It can easily do that because, well, we know most of the information. We know how much I/O it might take, how much CPU it might take, how much memory it's going to need, and it can easily figure out which one is the fastest way. And it just picks that from there and caches it. So if you're going to send that select statement again, we don't need to do this query plan again. It's just going to get that cache version and run it. So that's actually how SQL Server gets the data for you. In Cosmos DB, well, let's say we have the same select statement. In Cosmos DB, we don't need to do that much with the parse and bind. Why? Because, well, we don't have a schema. So there's really not that much to check out there. The first thing we are going to check, we want to be sure that select statement is correct. And then really we are ready to go and run this. So one important, tip for you. If you are creating Cosmos DB application, you want to be sure that you are actually creating a 64-bit solution, not 32-bit or not any CPU. The main reason for that is we have this local SDK named is service interrupt.dll. That is actually one which can create the query plan locally, not in the Cosmos DB. So if that does exist, you don't have to make a request to Cosmos DB and make a query plan. It can actually happen locally. So you want to be sure that your application isn't 64-bit. If that is the case, we are going to create the query plan, and we are ready to pull the data. Now, the next one is going to be, well, your SDK is going to actually check if you have the partition key. So that is pretty important one. If you have the partition key, then that means we can just hash that partition key and send this query only one database engine. If you don't have it, then things are going to get a little bit tricky, because then you can have 10, 20, 30 database engines, and we need to send this query to 20, 30, like different database engines. And it's going to take longer, it's going to take some time, and probably it's going to be expensive too. So after that, we are going to get the data from the SDK, and SDK is the place, that central place, that all that data is going to come in. And if we need to do any kind of merging, that is the place we are going to do. So, for example, if you are doing any kind of aggregation, let's say you are trying to maybe get the average of the ages, right? And you have 20 database engines. Well, SDK is the one which is going to do that aggregation. Database engine cannot do that because each database engine has no idea what other data they have. So all the data has to come to the SDK, and SDK is the place which is going to do that aggregation for you. That is one of the big reasons that you need the good resources for SDK, because there's a lot actually happening in the SDK for the NoSQL databases, because you are dealing with different many database engines, and that's the place that central place for data to come in and just do all that aggregation. Next one is data models. So in SQL Server, as I said before, Microsoft is really trying to keep up with the technology, and they are adding all kind of different functions to the SQL Server. So we have the relational database model. We have JSON objects. You can actually save NoSQL and SQL Server. You have the XML. You can present data as an XML. And also, you have the graph databases in SQL Server. So everything is great, but the problem is you are stuck with the T-SQL. So whatever T-SQL supports, you're going to be actually just using that. So there's some kind of limitation when it comes to like different, data models in SQL Server. In Cosmos DB, it's different. So we have the NoSQL, we have the MongoDB, we have Gremlin, Cassandra, PostgreSQL, and each of them is actually using their own native languages. So, for example, you have a MongoDB, and you're like, I'm really tired of maintaining this server. I want to just migrate to Cosmos DB. All you have to do is just, move your data to Cosmos DB and change your connection string in your API. Your API is going to think about it's just actually connecting to MongoDB when it's connecting to Cosmos DB. So you are going to use still the native language of each data models, so which is going to give you much more flexibility for the data models. Next one is indexes. So in SQL Server, as I said before, it has been out there for 30 years. So there's all kind of situation and all kind of index types SQL Server actually has. So those are the most common ones. As you can see, clustered, non-clustered, filter, and unique. Those are the most common ones. Those are equal to the range and composite indexes in Cosmos DB. We have the column store, mostly for analyzing data in SQL Server. In Cosmos DB, well, Cosmos DB is an operational database. It is not a reporting place. So your data scientists, your BI developers should not really touch your Cosmos DB. If they do, that's going to be an expensive query. So for that, there's a totally different storage for Cosmos DB. If you actually enable that, there's a fabric, and there is a different areas. It's just like move your data to analytical storage. It's much cheaper to actually, analyze the data out there rather than in Cosmos DB. Rather than that, we have the full text in SQL Server. If you want to do any kind of full text search in Cosmos DB, I recommend you to use the Azure search. It's much faster and flexible. then try to run any kind of like a system functions and try to find, run any kind of full text queries. Geospatial data is another one, SQL Server. Cosmos DB actually has that too. So when you create a SQL Server table, if you don't have any kind of primary key on it, there's absolutely no indexes. It is your responsibility in SQL Server to figure out which columns should be indexed. In Cosmos DB, when you create a container, everything is indexed. So you don't need to worry about what you should index. So, which works great, but the problem is, if you are going to keep everything indexed, your index file potentially can get larger than your data file. So you are paying for the storage. So it makes sense for you to kind of, after you go to the production, figure out which properties actually you are not using in your where filters. So you can actually exclude them and save some, the storage space for the index file. And also your updates, inserts will be much faster because they don't need to get indexed every time you run an update and insert. Indexes centralized in SQL Server, just like the database. In Cosmos DB, well, if you have 10 physical partitions, that means you have 10 indexes. If you are trying to do any kind of reindex, don't forget it, you are actually reindexing 10 databases. So it's going to take much longer. Because of that, in SQL Server, usually you create the indexes one by one. In Cosmos DB, well, you want to be sure that you make all those indexes together because you might be handling like tens, maybe hundreds databases. So you want to send that request once and be done with it rather than try to run it again and again, just like SQL Server. Next one is store procedures. Store procedures are great in SQL Server. You have to know the T-SQL. Everything is in T-SQL and SQL Server. They are read and write friendly. So they can do both, no problem. They give you a better performance because, well, most of the SQL Server store procedures get cached, and it's just give you a much faster and central place to actually run those queries. You can join tables, no problem in SQL Server. I mean, if you have the rights, you can even join the databases in different servers. So you can actually do that. In Cosmos DB, totally different. First of all, you must know JavaScript because all the store procedures are in JavaScript in Cosmos DB. They are write-friendly. They are not read-friendly. I'm not saying you cannot read data, but if you read data, we are going to have some issues because if you think about that replica set I showed you before, we have a leader and 3 followers. Store procedures will get executed only on the leaders, not in the followers. So if you are going to try to read data with store procedures in Cosmos DB, potentially you are actually pushing leader to read data when it's busy with updates, insert, and deletes. So can it do it? Yeah, but it's really a not good practice to read data by store procedures in Cosmos DB. Everything is specifically one container, so that means you cannot join any containers in Cosmos DB. And you can implement easily transactions by using the store procedures because, well, if you're in JavaScript, if something fails, what happens? Whole thing just freezes, right? So you can easily do that and use the transactions by the store procedures in Cosmos DB. Next one is triggers. So triggers are great with the SQL Server. You can actually, they get auto trigger automatically. They are special store procedures, which means they are still in T-SQL. We have 3 types of triggers, DML, DDL, and Logan triggers, and they, as I said before, they execute it automatically. So in Cosmos DB, they are special store procedures. That means they are still in JavaScript. We have 2 types of triggers, pre-trigger and post-trigger. Pre-trigger happens before the transaction, before any data changes. So that is actually a great place to validate data before do anything. That is a good place to actually do that. And post-trigger happens after the transactions. And one of the biggest difference is all of these are getting executed manually from the SDK. So you are responsible to actually execute them. They won't get automatically executed like SQL Server. Next one is computed columns or computed properties, depending, I guess, which system we are talking about here. Computed columns are great in SQL Server. Those are like virtual columns. You can make them physical column if you like by just indexing them. And they are visible out there whenever you write select all of them comes up on the screen. And they are indexable. So they are great. I use them every day. In Cosmos DB, they are pretty new. I think they just came out generally available, I think, this year. So one of the biggest challenge I have with that is they are not visible when you say select all. So you kind of need to know by heart the name of the computed properties so you can use them. You can access them by SDK. You can list them if they are there, or Azure Portal actually has that too. You can actually see them. But select all is not going to actually show them to you. They are indexable, and when you make them indexed, they are working much faster. They can actually save money. So in NoSQL, everything is case sensitive. So you might be using like upper or lower functions in your where clause. If you are doing that, you can actually use computed columns and create a function for that, a column for that, and call that computed column rather than looking for lower or upper. So that can actually save you some money if you want to use them. Next one is pricing. Well, we can talk about SQL Server pricing all day, I guess, because it's pretty complex. So there are different ways to actually pay for the SQL Server, and those are the kind of ways to, I guess I'm not going to go in detail in that. But in Cosmos DB, there are a couple of ways. So the first one is the manual threshold. So for every single region, for 100 request units, you are really paying almost like $6 per month. So you can do that easily. The minimum unit is the 400 request units. So for minimum, really you're going to pay somewhere between $25 to $30 for the Cosmos DB per month. You can easily pick the serverless. Serverless is just like you pay as much as you use. So that is actually great for dev, QA, and a kind of proof of concept application. You can actually do that by the serverless, and you can easily convert that to the regular threshold later if you like to use that. So as I said before, there are two layers in Cosmos DB. First, you are actually paying for the request units, and the next is you are paying for the storage. So for storage, it's pretty cheap. As you can see, 1 gig is 25 cents per month. So depending how much data you have, I guess that's going to be an addition on the cost. As you can see, analytical is much cheaper. So it is important to kind of move all the data that you want to analyze to the analytical storage, and don't keep them in the operational database. That will keep your database smaller, and your queries work much faster because you have less data. So have some kind of retention policy. After 2 years, if you don't care about the data, just use one of the Cosmos DB actually has a TTL functions, time to leave function. So you can actually put easily 2 years, and it can delete it for free for you. So that will actually help you to keep the database size, I guess, easy. Also, actual dynamic auto scale per region just came up, and that's a great one to actually save if you want to have multi-region applications. With that, in before, if you have two, for example, regions, and let's say one of them might be in Asia, other one is in, let's say, in United States, right? So when the actually night happens in Asia, and United States gets busy, you are still getting charged what United States highest number in Asia. So with the dynamic auto scale per region, actually it's going to work different now when people goes to sleep and your application goes, I guess, not very busy. Then you're going to get, charged for the minimum rather than what actually United States is the highest one. Next one is views. So views are very useful in SQL Server. That actually keeps, you might be joining many tables. So you don't really need to, I guess, know all the joins. You can just create a view and get the data from there. You can actually materialize them easily by indexing them. And I use them every day, and they are very useful. In Cosmos DB, there is really no views. So you kind of need to come up with your own view by using different features of Cosmos DB. So materialized views are actually in private preview or public preview right now. You can try them if you like. It kind of almost what it does is, let's say you have the orders container, and you want to create a materialized view, you can easily create another container named order2, for example, easily by changing the partition key or anything like that. Now, let's actually see them, how that works. So change feed function is the one we use for materialized views in Cosmos DB. So it looks like we have a container named orders, and our partition key is customer ID. Now, everything works great until we end up with a query that does not have the partition key. So we are looking for a specific product here, and product ID is 200. Well, we have 2, 4, 6 database engines out there running, and since we don't have the customer ID in our select statement, this is going to be a cross-partition, and it's going to cost us 49 request units because, well, I'm getting charged from each database engine. Now, if this happens a couple of times a day, I guess it's really not a big deal. But if this happens a lot, that's going to give you a lot of problem because in here, you are really just, losing money because not for a good reason. So we kind of need to come up with some kind of solution for that, because if you don't, this is going to get even worse. How? Because your data is going to get even bigger, and you're going to end up with maybe 1, 2, 3 more databases, so that 49 is going to even go higher later. So this is really not going to fix itself at all. So to fix that problem, what we are going to actually use is the change feed function. Change feed function is the CDC of SQL Server. So data change comes in our orders table. Our partition key is customer ID. Now, change feed gets triggered, and we can actually get that trigger in 2 places. I use the Azure functions because that's much easier. Cosmos DB is already in Azure. Azure function is already there, so it's much easier for me to use the Azure functions. When the change feed is gonna get trigger, Azure function is gonna get the data and figure out what is changed, and you can do whatever you like to do out there. In my case, I create a new container named orders under product, and my partition key is actually different here, product ID. It is the same data, only difference is the partition key. So in that case, you can actually easily do that with the materialized views I just talked about. It's still in preview right now. You can do that, but that is really the way that to do before actually that becomes available. So in that case, now I have the product ID. Rather than actually using my orders container, I am using my orders underscore product container. So from 49, actually, everything goes back to 8 request units. As you can see, you can easily save a lot of request units if you have any cross-partition, common cross-partition queries like that, and you can fix it like that very easily. So in cloud, storage is much cheaper than the CPU power. So that's usually how you fix the problems in NoSQL databases. In NoSQL databases, it's okay to duplicate the data, and this is a kind of good example to show you the benefits of the benefit of fixing this by syncing the data and duplicating the data. Next one is performance tuning. In SQL Server, that's a whole job title out there. Many people out there, just their businesses just make the performances better, do the SQL Server faster. So I guess there are a couple of things you need to, pay attention in SQL Server. You want to select only what you need. You don't want to just always select all and get all the data. You want to look at the missing indexes. If you are missing indexes, those might be very easy to fix in SQL Server and fix a lot of problems. You want to be careful with the query hints. Query hints is like in SQL Server, you almost tell SQL Server how it should get the data. So in some cases, it might work, but at the end, SQL Server is going to actually know much better than any of us how to get that data much faster. So whatever query hint might actually work today, but as your data is going to get larger, it might fail later. So just be careful if you're using any kind of query hints in SQL Server. Look for the parameter sniffing. That's mostly for the store procedure. When store procedure gets created, it creates some kind of like a query plan. As I said before, your data is going to get larger and larger. That query plan might not be the good way anymore, but it's cached. So you want to kind of look at the parameter sniffing for the store procedures. If you have any kind of problems in SQL Server, execution plans gives you all kind of information about what is really happening in the SQL Server, and it can really show you where the problem is easily. And also, if indexes are not enough in SQL Server, the next level usually is the partitioning the data. So that's how you usually do the performance tuning in SQL Server. Cosmos DB, similar, at the end it's a database. So you want to select only what you need. So if you really think about it, that's even more important in Cosmos DB because your service is on the cloud. So it's gonna, the SQL Server, if it's in the enterprise on-prem, okay, it's in the same network at least. But in Cosmos DB, it might be just even far away from your area. So just select only what you need so that request and response might be much smaller packages for the Cosmos DB. Missing indexes, you can use the indexing metrics. This is available in SDK, and you can easily figure out if there's any kind of suggestions from the Cosmos DB. Maybe you are missing any kind of indexes. Cosmos DB actually suggests you that. So you can enable that and see if you have any kind of indexing metric suggestions. You can use the point read. Point read is an interesting one in Cosmos DB. So let's say your data model is 1 kilobytes. If you want to actually run a query and get one document from the Cosmos DB, that's going to cost you minimum 2.6 to 3 request units. If you will use the point read, that's always going to cost you 1 request unit. For point read to work, you must have the partition key and you must have the document ID. So if you can actually make those 2 IDs available in your application all the time, Cosmos DB can get really, really cheap because it's just going to cost you 1 request unit to get 1 document. You can use the materialized views, the one that I just showed you. If you have a lot of cross-partition queries, then you can easily use the materialized views and kind of try to tackle problem with that. For the retention policies, as I said before, you want to keep the hot data in Cosmos DB. Whatever matters should be in Cosmos DB. If you are not using it, just have some kind of retention policy and work on just removing it from the operational database. Also, we have the execution metrics. You can use that. They are not as good as the execution plan of SQL Server, but they still give you some information about what's really happening in the backend in Cosmos DB. Next one is null and undefined. So those can be problem, doesn't matter which database it is. In SQL Server, null is neither an empty string nor a 0 value. So when you say null is equal to null, it just says false. So you can use is null or is not null to handle null values in SQL Server easily. You can be careful with them because some of the aggregations, they are not really null friendly. For example, when you say count, it will not count on null rows. Or same with the average. So the number you are ending up might be a little bit different than what you were expecting with the null values. Cosmos DB, it gets worse. So in Cosmos DB, first of all, that's a NoSQL database. That means if it's null, you don't need to keep it there because you are not, not like SQL Server, you have a column name out there, I don't know, age. If you don't have the age, don't keep it in your, the data model. That will be the best way to go to handle the null values in Cosmos DB. Because when you actually have them, the problem gets bigger. For example, aggregation, and there's only 1 null value. Let's say you have 1 million documents, but one of them has null in it. The function is not going to run, and it's not going to return anything to you. So it's important not to keep null values in Cosmos DB or any other NoSQL databases. You don't have to keep them in the data model. Next one is data modeling, which I'm going to actually have another session coming up just for that, because that's a whole kind of, topic for itself. Data modeling in SQL Server is like, everything is relational. So we don't want to duplicate all the information in SQL Server. So it's very flexible. You have different, it's almost like making your own sandwich, all the all the ingredients. You can just pick them whatever you want, and every time it can be different. You can join tables. but that actually creates a constant pressure on the query optimizer. So everything is great, everything is working fine. It's a totally different, I guess, way in NoSQL databases. In NoSQL databases, you better know who your customer is. So you're not gonna let them join any kind of, because there's not even an option for that. So you better know your application or the service which is gonna use the Cosmos DB. For example, let's say you are creating an application. Think about the Amazon product page, right? You exactly know that what that product page is gonna actually want from Cosmos DB. If that is the case, just put in data model what it really needs. In, I guess, other words, just know your customer. If your customer is a vegetarian, don't make, I guess, Italian in a data model out there, because it's not gonna work. Nobody's gonna come and, like, buy that for you. So it is important that, know that there's no joins. And also, there's no schema. Normalization does not work. So if you are actually moving from the SQL Server to Cosmos DB, the worst thing you can do is keeping the data model as it is. You are going to end up with many containers, and you need to make many requests, and that's going to actually cost you more, I guess, running the CPU. Number of requests is going to be higher, and that solution is going to be very expensive in Cosmos DB. So you want to be sure that, if you are moving from the SQL Server or any kind of relational database to Cosmos DB, just don't take the data model as it is and try to, keep those tables small. Now, everybody came here for this question, right? Which one should I use? So, in older days, this was an easy question. Why? Because, well, SQL Server is a relational database. Cosmos DB is a non-relational database. Well, unfortunately, that is not the case anymore. In SQL Server, it supports the JSON. It supports the XML. So you can actually easily save NoSQL data model in SQL Server. So if your application is a small application, it's not going to be a global application. It's something just for the, internally I guess, the enterprise database. You can easily use SQL Server for a NoSQL environment. I do in my end. If it's a small application, I can easily save my JSON objects out there, and you can easily use the in-memory tables, and you can make things really, really quick in SQL Server, as long as you don't worry about the scalability and globalization that much. So SQL Server can actually give you that functionality. The scaling is going to be the problem, and the best thing about the SQL Server, it is available on-prem. So, if you have the SQL Server already, you don't really need to know another cloud subscription. You don't need to worry about all this kind of like the firewall rules and other stuff. SQL Server is there. It's a good option. And also, when it comes to the aggregation, SQL Server is the king. You can do all kind of things with the SQL Server. SQL Server can be an operational database. SQL Server can be a database for analytical stuff. So SQL Server is a good option. Cosmos DB is a totally new generation. So non-relational database? Not really, because actually it supports the PostgreSQL. So if you have the PostgreSQL, you can make it relational and use the Cosmos DB for that. If you are worrying about the scalability, if you are worrying about the globalization, Cosmos DB way to go. If your application is already in cloud, well, probably Cosmos DB is way to go, because it's going to be much easier to connect and do all kind of features that on-prem cannot give you. You have different consistency levels. If that's you can actually make things much more flexible in Cosmos DB. You don't have only eventual or the strong. You have actually 5 different levels in Cosmos DB. Global distribution with multi-region right. So there's all kind of options you can actually Cosmos DB can give you, and most of them is really for the high scalability, globalization, and is very all the new features coming up. Cosmos DB is going to be probably the first one is going to bring that to you, because at the end you don't need to buy another, I guess, version of Cosmos DB. When something comes up, it becomes available in the cloud. So how to start it? In SQL Server, Well, there's all kind of tools that you can use. SQL Server Express, developer version is usually free. You can use the SSMS. SQL Server, as I said before, it has been out there for 30 years. So there's a lot of tools, a lot of information about SQL Server. And if you are actually just starting and trying to learn about the databases, SQL Server has been out there for a long time. And most of the companies is going to have SQL Server so it's kind of good to know about the SQL Server because most of the job requirements probably is going to need the SQL Server knowledge. Cosmos DB, if this is the first time you are trying to read or learn, you don't need a subscription. You can actually get the emulator. Emulator is free. You can download it, and it will work locally on your machine, and it will just act like a Cosmos DB. So you don't need a subscription. You can still learn Cosmos DB and use the emulator for the dev and QA environments too. There's a serverless option that is great for the dev and QA or proof of concept. You can easily use it, and it will charge you only for what you need or what you actually use. Also, Cosmos DB has a free tier. There's only one for each subscription, and that will give you 1,000 request units free and 25 gig for free. So if you are learning, if that's the first time you want to kind of deal with Cosmos DB, be sure that you have the free tier. That will give you 1,000 request units and 25 gig for free. As you can see, those are the SDKs Cosmos DB actually has, so it's available in different languages. Now, after this, I'm going to actually show you some of the Cosmos DB in action here. But if you will have any kind of questions or anything like that, please, follow me from any of those social media. I'll be more than happy to answer any of your questions there. If you want to learn about Cosmos DB and maybe pass that exam out there, the certification, I work with Steve Flowers to actually review this book. So that will be pretty helpful if you want to kind of, learn about it more. So now, and also the demo that I'm going to show you for the Cosmos DB SQL Studio, you can download it from there, or you can actually download from VS Code directly. So let me actually open my VS Code here. To be able to download this, you can easily go in here, the extension, and search for the Cosmos DB SQL Studio, and it should just come up here. Now, when you actually put the connection string here, the first thing you are gonna see here is it's gonna list all the databases available on the top left here. After you pick that, it's gonna show you all the containers. As you can see, I have a bunch of containers here for demo. So we talk about the physical partitions. Now, you can easily see how many physical partitions this container actually has. So in here, it looks like I have 5 physical partitions, and it gives you all the hash numbers too, as you can see, we talk about it. So those are actually controlling how we are finding the data. For example, if we are gonna go and run this query, as you can see, it's a very simple query. But if you think about it, there's a lot actually going on here for a NoSQL database. So I want to get top 10 from C. What is C? C is the container that I just picked, which is the posts. Now, if I actually execute this one here and look at the results, well, I get top 10, right? No surprise out there. So there are a couple of things actually happening here. First of all, my request charge is 12.90. For a simple query like that is pretty expensive. And 10 items return. But actually, this is kind of lying to me. Why? Because if I go and look at the execution metrics, as you can see, since I don't have the partition key in my query, this top 10 actually went 5 different servers. And I get actually 50 records, and SDK is actually showing me only 10. So as you can see, number of requests here is 5. I can easily click here and see that SDK made 5 requests, and each of them actually cost me this much request units. Also, retrieve documents is 50, not 10. So you kind of need to be, careful. This is kind of nice to kind of show you what's really happening in the backend with the NoSQL databases. So if you have, 100 databases, you are going to end up with a lot of request units here and a lot of documents that you are not even going to see on the screen. The next thing I can show you is I can easily show you the indexing metrics. So rather than writing your own code and try to figure out what indexing metrics Cosmos DB suggests you, I can easily, for example, run this select statement here. I am looking all the posts by this user, and I'm looking for score is larger than 10. So when I run that, it's going to take a little bit longer. It's still 24.10. The main reason for that is my partition key is, I believe, is the post ID. Since I don't have the post ID, I am running this in every physical partition I have. So I can easily go here. As you can see, index and metrics becomes available, and it shows you. In the left side, it says, well, I am using the owner user ID, so please do not touch that, don't remove that. In the right side, potential indexes, those are the indexes it suggests me that you should actually create. It looks like score is not indexed. So if actually create a score, that's going to probably help me with the requests. You can easily go and look at this indexing policy here. As you can see, excluded properties in here. Looks like post body score is not indexed. Post body makes perfect sense because that is the one, actually all that description, all the information is. I'm never going to use that in my where clause. So it really makes sense to kind of exclude post body. But score, in this case, might not be a good, to exclude. So this actually helps me to figure out where the problem is. Rather than that, we have results. You can easily do a kind of like a query analyzer. You can actually start this here. When I run this, it's going to show you some of the most, important properties here. As you can see, looks like I am having an index problem. You can easily see it here. So if I'm going to go and, I don't know, let's make this one 2. But probably what's going to happen is you're going to play with the properties, try to run this in a different way, and you can execute it. So you can actually see when you change it, when you change the query, how it's going to actually change in the process. So you can kind of easily go back and compare the queries and figure out which one is the best way or fastest way for you to run. The other one is the data analyzer. So you don't really need, a Tableau or any kind of big, report options. So if you are looking something really simple, for example, if you want to kind of look at the scores, you can easily see, okay, this is the minimum number, this is the average number, that's the max. So that kind of gives you, rather than taking this JSON object out of here and put it like in an Excel file and try to figure out what is minimum, what is maximum, this gives you kind of like a simple, option when it comes to analyzing the data. I have the map here, but I'm not going to go in that. If you have any geospatial data, you can easily create your polygons and figure out what data is under that. So I'm not going to go in that. That's a kind of whole big topic for itself, but it's an option out there for you. And one more option here is the point read. Point read is how you actually read the data the fastest. And you can easily see the post ID here this is always going to change. That's going to show you what the partition key. So if you pick the partition key here and document ID here, it should be the fastest way to get the data. So yes, actually try. Post ID is 16. And document ID is this number here, GUID. And put it right here. And just click on read and cross fingers, right? So as you can see, request charges 1 or 5. So that is the fastest way you can read data in Cosmos DB. So whenever you are architecting your application, if you have some kind of like a grid, for example, you want to be sure that in every row you have partition key and document ID of that row presents. So when you click it, rather than running a query, you run a point read to get that row information. So that will make things much faster and cheaper. So that's the fastest and cheapest way you can read data from Cosmos DB. But with that, I think that's all I have for you. This one is actually free. I'm doing this for community. I'm still working to make this open source. So if you'll like to help me, I guess, later, you can find this in the GitHub. It's not open yet, but I'm still working on it. And everything in VS Code has to be JavaScript, so that's using the JavaScript API. And yeah, it will be open source soon. So thank you again for coming to my session, and hopefully I will see you in the next session. Thank you.